Hello, fellow YouTubers. Okay, we're back. I'm sorry for the, I apologize for the mess here. It's it's a bunch of spaghetti, and so it's a little messed up, but you know, try to keep this as organized as possible. But in this video, we're gonna show how you can run the rotor in the motor. By the way, this motor is just a basic motor. Okay, a motor and a generator at its most basic form. Really, every motor is a pulse motor because every motor requires a switching of on and off, power on and off in order to rotate the magnetic field. So this is just a basic, motor. Is all it is. I'm sure there are way more efficient motors out there, but this is to show just basic concepts. So what we're going to be showing here is we're going to be running the whole thing off of a large capacitor, and its output is going to be charging a smaller capacitor. Okay, and this is to show that we can indeed get more joules stored in this than what came out of this. Now, I tried to run this thing up from a dead start using just this capacitor and to power it, and it won't work. It's just not enough power. I mean, it'll push it a little bit and maybe give it like one rotation, but that's about it. So I try to show this just by letting it start from a dead start, from a complete standstill, and get this to power it up. But it won't work because it doesn't start switching fast enough, and it just drains away the power in here, and then like it stays on so long, it just wastes the power away, and then it never switches it off at this reed switch down here. It never switches it off, so there's no magnetic field to collapse and then to store in our other capacitor. But and of course, there's no way it's going to generate anything like that. So I have to run it off a battery. Okay. So I have the capacitor connected to the battery. It's just a simple parallel connection where the positive's going to the positive and the negative's going to the negative. Okay, so what we're going to be doing is running the thing from a battery and capacitor. And of course, the capacitor is going to charge up to the voltage level of the battery, and they're both going to be running everything, and we're going to get this up to speed. So this rotor here is acting like a somewhat high frequency switching. It's acting like the switch, our reed switch, and simultaneously act as a generator, past our generator coil, so we can generate. And I have the sorting circuit on here as well, and I'm powering that with a little wall adapter here. I'll turn that on here in a minute, and so I'll turn that on here too, but because I have this capacitor sorted at 0, so we can see that it's starting from 0, and there was nothing in it in the first place. And so what we're going to do is we're going to get this up to speed in the resonance, which resonance is basically just when you've got the maximum spin of power here, mechanical, while the electrical input is at its minimum or its lowest. So this is any motor really, or pulse motor. Okay, an analogy would be when it's spinning in its resonance. It's like pushing somebody on a swing in the park. Okay, you know, at first it takes a lot of power to build up the swing, but once the energy is stored in the swing, and the swing is at its maximum energy storage, the amount of power in pushing it becomes smaller and smaller, and all your energy is stored in the swing. Well, same thing with the rotor. Spinning mass stores energy. So now, you know, some people may argue, you know, all the energy is coming from the battery. Well, it is. Okay, but what we're going to be doing is taking the battery and the capacitor, getting this up to speed, and then once it gets up to speed, we're going to just basically disconnect the battery. So the battery is going to be over here, and it's going to run, and then I'm going to disconnect the battery completely so it's running off of the capacitor. And I'm going to give I guess a link to a capacitor charge calculator that you can go to and do this for yourself, and I'll show the formula for that calculator. But I'm not going to, you know, I don't like using that formula. The calculator is a lot easier, and but the formula works, and it's to find joules in these capacitors. So, you know, when I disconnect the battery and it's running off the capacitor, this capacitor is like a 10,000 microfarad 50 volt, and when it's fully charged to about 12.01 volts, about that of the battery, it is actually storing right around, you know, you can go calculate this for yourself. It's actually storing around 700 millijoules of energy, and this actually requires about 130 volts at 82 microfarads to equal the same 700 millijoules in here. But I'm going to show that we can actually get above that 130 volts before this one even drains down, to show that we can store more joules in this one than what's used up in this one. And the 700 millijoules isn't even actually used all the way up. You'll see that there's still some voltage left, you know, but it's just to show how much power is actually running, is required to run this, and it's going to be like pretty much the same thing that's coming out of the battery. Okay, but so we're just we're looking at this in a certain time window, you know, from the very moment we disconnect this, and the very moment that it's running from this and charging this is what we're going to be looking at. And you'll see there's more joules. So I'm sure I probably missed something. It's a lot of information here, but we're going to start this up, and this meter is to show the power in this capacitor, and this meter is to show the voltage in this capacitor. So we're gonna get this show on the road here. Probably turn these on so you can see, and I am using this coil shorter, and I know I said I was going to give a schematic on that, but really this isn't a preferable circuit. I mean, it just does an okay job. It's not doing exactly what it needs to do, but it does a good job. Really, it'd be better to get a reed switch that is being triggered by, say, a rotor like this that's attached to this rotor right here, so they rotate together, and you could have smaller magnets attached to that. Well, not even these, but more like something like, you know, like this, something smaller, so we can get that quick triggering, quick, you know, if we can use it to motorize it in our motor coil to pulse it, so it uses even less power, and also we can use it to trigger. We can get rid of this thing right here and use it to trigger our coil shorting for even more power from the generator coil, because this uses power. Yes, it uses power right here. Okay, but that doesn't have anything to do. It's just to run our switch, and that is all. Like I said, a reed switch will do exactly what this does, but it'll do it even better, especially if using tiny little magnets on this, rotating with this rotor. So when we get that nice little short there, then we can eliminate this and the power required, which isn't a lot because it's just a switch. So we're going to do this right now. We're going to start this up, and I'm going to have to put the camera down because when this reaches a certain speed, you know, I'm going to disconnect the battery completely, and the meter will show the volts and that bigger capacitor running everything, and this is the smaller one that will be collecting. And later on I'll do like a side-by-side comparison of just the generated power, normal generated power, charging our output capacitor here, and compare that to just the magnetic field collapsing out of the motor coil and charging that. But right now I have both of them combined together, but not connected quite yet right here. So here's the steps. This is the process that's going to happen. I'm going to connect it, and you know, run it from the battery and the capacitor, get it up to speed, full speed resonance, and then we're going to disconnect the battery so it's running off the capacitor only, and then we're going to connect both our generated power and coil shorting power, which is right here, plus the collapsing magnetic field coming off right here, and we're just going to connect it right here to start charging that. And then I'm going to press hold on both of these, and then we're going to do a quick calculation and so you can see that we can have more joules than the joules required to run everything. So let me get a sip of coffee here. Okay, so this hopefully this doesn't fly into the ceiling, but well, we'll give it a little head start here. Okay, and then we'll run it up. Oh, I should probably take this short off, huh? And this is the show. There's nothing. We're starting from 0, and then this is just a little bit coming from the rotor. So we're going to take this off, take the short off, 0, okay, and we're going to get this running. Hopefully I can do this all in one shot. Here we go. There we go. And I'm going to connect our AC, our AC switch. See, it's getting up there, getting up the speed, and I'm going to put this down for right now because I need both hands for this part. Put it right here. Okay. letting it get up to speed, and this is at 11.93 volts here. I'll show you. It's running pretty good right now. So 11.94, that's the battery and the capacitor combined together. And this started out, excuse me, this started out at 11 or about 12.03 or so. And of course there's nothing going on here yet. That's our output capacitor. And I want you to see something here on this voltage of the battery, which is, you know, it's right here. It's the capacitor and the battery. And I want you to watch the voltage here going across this battery and capacitor. Probably won't do it now, but the other day it actually went above the voltage where it started. I guess I used a little too much power from the battery from previously, from yesterday, but it's hauling pretty good. Well, it looks like that's about where it's gonna be steady at. So here we go. Down so I can switch this. So all I'm going to do is I'm going to disconnect the battery right here and let it run off the capacitor. Then I'm going to connect the collapsing magnetic field from the motor and the generated shorted power to get more power from the generator coil at the same time. So here we go. I'm going to disconnect. I'm going to reconnect here. So there we go. There we go. And see, we still have 7 volts. So we haven't even used up all 700 millijoules. This is already past 700 millijoules, which happened at 130 volts. And like I said, I'll do a comparison test on just the normal generated power alone, and then compare that to just the collapsing magnetic field alone. So there goes. I'm going to pause this now. I'm going to hit hold. It's still climbing. And you see there isn't a lot of Lenz's law on this rotor. It's not even connected to the battery. I already took the battery off there, and there's still 4 volts left in our bigger capacitor, and we're still getting a high voltage into our smaller capacitor. That's pretty good, actually. But so we see, you know, if this ever drops to 0, starting from 12 volts, then you can say we've used the full 700 millijoules. This is almost at like probably 1.4 joules, just like twice the amount of joules over here. This being almost less than 700 millijoules. And okay, I'm gonna pause it. Hold on a second. Mute that, or hold it. Let it go up a little bit further. Okay, right there, it's starting to drop. There we go. Okay, then you see it's still running off no power, but I'm going to disconnect our AC switch because we don't need it right now. Save our power. So here it is. We're left with, we started at 12.03 or so volts. So really, what we need to do is subtract this voltage from the voltage we started, and find the joules, the amount of energy from the difference between those two, and we should find how much actual millijoules we've used compared to how many millijoules we ended up with over here, which is going to be more than 1,000 millijoules, which is 1 joule that we stored right there, and it's still running. And another thing is, I might have to make a whole nother video on this, but our capacitor has to be tuned with this. So I mean, yes, of course, if you have a small capacitor right here, also depending on the distance here between the rotor magnet and the stator, the generator coil, that makes differences too. But when this, depending on the size of this, of course, if you have a smaller capacitor, you're going to get like a smaller amount of power, and it's not going to drag down the rotor as much. But that's what the coil shorting circuit or reed switch is for, is to give that extra burst of energy up into a smaller capacitor. So you want to find a capacitor that is like, it's just the right size. If it's too small, you won't get enough power. If it's too big, you'll get too much power, and you'll load down the rotor. But like I said, I'm going to explain that in another video. So it finally has come to a stop here. So I'm gonna put up a picture here, I guess, of how much energy is actually stored and how much was used. And I'll put the link to the calculator so you don't have to use that silly formula to calculate joules in a capacitor. Now, another thing I want to say about a joule. A joule is equal to 1 watt second. So it's kind of confusing to me, because the joule is supposed to be how much energy is stored, energy in a capacitor. Yet at the same time, a joule is equal to 1 watt second, and that 1 watt second, to me, it's a watt. That's power. So it's not just energy. So it's actual power, a watt for 1 second. So that's a pretty good, way of measuring how much power you've actually used and how much power you've actually stored and got out of it. Now, some of you, out there might try to argue that, well, what about all the power required to get it up to speed? You use a lot of power at first when it's starting out slow. Just like a swing, you have to have a lot of power, input power, pushes. But once the swing gets up to speed, the power required to go into it becomes smaller and smaller. So if you are able to maintain your output power without slowing down the rotor or minimizing the Lenz's law, and you are able to continuously get your output power back out, okay, without loading down anything, you can recover what you lost in getting everything started. But we had to do it that way because we had to get our switch up and running to a decent speed, so we don't waste away all our power right here. So this is actually like showing us, it doesn't matter if it's running from the capacitor or the battery. Either way, it's using a small amount of power, and that could be shown by disconnecting our battery and running it off the capacitor. You saw that the voltage didn't even get all the way down to 0, because all the energy, yes, is stored in our rotor, because spinning mass stores energy. But the power required to keep the energy stored in there is very small, and that's what we're showing here, and how much joules or millijoules were actually used. And of course the output, or the energy stored, is converted and shorted out for even more power, and then stored right here. And we can see that we have more joules or millijoules or joules coming out and stored right here than what was used. And a millijoule to me is power, because it's a 1 watt second. Well, a watt is power, but you know, just for 1 second. So it's actual power, more power out in this capacitor than in that comes from this capacitor. And like I said, you can eliminate all this in the power required to run this if you use a reed switch on like a small little rotor that you can fit next to this, and use the tiny little magnets to get your quick switching at the right time, the time that you need. And if you get that just right, you won't slow this down, and you can maintain your power coming out. And you need, in order to use this power, you have to disconnect it completely from your generator coil, and then dump it to whatever load you're running, whether that's from the battery running everything or into a light bulb or whatever. But you need a 2-stage circuit, and or you can use another reed switch. You can use another reed switch and just dump the capacitor when the generator coil is in between magnets. That way you don't have to have a switch to disconnect the capacitor from your generator coil. You can eliminate another switch, electrical switch, and just use another mechanical switch, but in between magnets, like that. That way the load and the capacitor will not load down your rotor, because the opposing field from Lenz's law will be happening in between magnets, so the rotor won't be loaded down, or it won't fill it. And that's how you get the energy out from your capacitor and generated power and coil shorting. So anyways, I'm at the end of the time for this video. I'll put a link down below so you can see you know, everything. I know I haven't, like, I don't make schematics for everything, but I'm probably going to make a schematic for this, and it's real basic and simple. It's just a switch, a coil, and a battery. And you can use reed switches for the coil sorting. But anyways, I hope you liked this video. If you're new to this channel, please subscribe. Thanks for watching. See you on the next video.